last time I started, or we learned, if you have a force which is already inclined force, so we have the option to break this force to two components, one horizontal and one vertical component, using right angle triangle or using a given theta. The current situation right now, what will happen if you have horizontal component and you have vertical component, and I am looking for what is the original force is, and what is the inclined angle theta with the horizontal is. So the current situation, we have horizontal force, we have vertical force, and I'm looking for what is the total force, what is the original force for these two components. It's very simple. The original force F equal square root of the horizontal component square plus the vertical component square. So if you have the horizontal and the vertical components and you would like to go back to the original force, go ahead and use this expression. The original force will be square root of horizontal force square plus vertical force square, and the angle theta equal this angle with the horizontal force or with the horizontal component equal inverse tan the vertical component divide the horizontal one. The angle theta with the horizontal component for this force F equal inverse tan the vertical component divide horizontal component. Be sure, if your horizontal force like this or vertical force like this, what will be the original force? Your original force will be like this, F, in between this component and this component. And your angle will be with the horizontal, theta. So your force equals square root for horizontal component square plus vertical component square. I don't care about the sign, positive or negative, because your component will be square. So I don't care, positive or negative. And your angle theta with the horizontal equal inverse tan vertical component divide horizontal component. Also, I don't care about sine or cosine. It's not my concern. I don't care. I don't care. If your components looks like this one is here and this one is here, horizontal one and vertical one, your original force will be like this. And your angle theta will be here. So your force equals square root h squared plus v squared, and your angle theta will be inverse tan vertical divide horizontal. Any questions so far? Yeah, you can use X and Y. That's fine. It's just symbols. Let me go back to example number 2. We have a horizontal force F1 equal 383.2 Newton, and the vertical force F2 equal 296.8 Newton. I'm looking for what is the resultant force F. this component, I will assume this one is a component and this one is a component. What was the original force? This original force can be called the resultant force. So I'm looking for resultant force for two forces, one horizontal and one vertical. Your resultant force FR will be square root of the horizontal one, 383.2 square. I don't care about positive or negative. Plus the vertical one, 296.8 square. That means your resultant force will be, just a second, 296.8 square root. Your answer will be 484.7 Newton. Your angle theta with the horizontal one will be inverse tan 4. The vertical component, 296.8, divides the horizontal one, 383.2. Your final answer will be an angle, divide 383.2, 37.75 degree. So last time we learned if we have force, we can get the horizontal and vertical component. Right now, if you have horizontal force and vertical force, I can get the resultant force R. Let me solve this example to see what's going on. Example number 4. I'm going to solve example number 4. Example number 4, we have three forces, F1, F2, F3. And we are looking for what is the magnitude of the resultant force. We need to add these forces together. Actually, I cannot add 600 plus 800 plus 650. I cannot. Do you remember? Do you remember last time? I cannot add these forces at this moment because each of them has different direction. F1 going to this way, F2 going to this way, F3 this way. So I cannot add these forces at this moment. So what should I do? I need to break each one to two components. Let's start with for F1. What do you have with F1? I have F1 like this. I would like to be more organized in solution. More organized. The given angle is 60. And I'm looking for the horizontal component. It will be like this. And the vertical component, it should be like this. I believe F1 and this component adjacent to the given angle. So this component will be F1 cosine 60. And this one will be F1 sine 60. F1 is given 800. So we have 800 cosine 60. How much? 800 times cosine 60. Your value will be 400. And 800 sine 60. How much? 692.8. This is for the first force, F1. Keep going. For F2. What's going on with F2? I have F2 looks like this. And the given angle with the vertical line, how much? 45 degrees. Actually, I'm looking for the horizontal component that will be in this direction. And the vertical component, that will be in this direction. What's going on? What should I do? The component adjacent to your angle is cosine. So we have here F2 cosine 45 degree. And here will be the other component far away from the angle will be F2 sine 45 degree. F2 is given how much? 600. So I can figure out this component and that component. 600 times sine 45 degree. Your value here will be 424.2. And this component will be the same, 424.2. What else? What do you have else? We have F3. What's going on with F3? So, for F3, here is F3. Actually, we don't have angle, but we have right angle triangle. So I'm looking for, this value is 12. This one is 5. This one is 13. I'm looking for the horizontal and vertical component like this. Do you remember last time how could I do with F3 with right angle triangle? The first step, please pick up an angle. Based on your choice, I will deal with that triangle. So as you like, probably I will select this angle, theta. Any question? Okay. So I will select this angle theta. So remember this angle, I believe, with V shape equal to this one. Anyway, this component will be F3 cosine theta. This one will be F3 sine theta. Your right angle triangle, which is 12, 5, 13, and your choice of this theta equal to this one in the right angle triangle. So sine theta equal to the opposite, divide 13. Cosine theta equal to the adjacent, 12, divide 13. So what should I do? F3, how much? 650. Time cosine theta. What is the value of angle theta? I don't know. I don't care. Cosine theta equal 12 divide 13. So cosine theta is 12 divide 13. Your final answer will be 650 times 12 divide 13. Your answer will be 600. What's going on? Please try to mute your mic, please. Anybody, please try to mute your mic. The second one is the second component, F3, which is 650 time. What is the value of sine theta? 5 divide 13. So 650 times 5 divide 13. This value will be 250.
It's a video, is that it?
Guys, can you mute your mic, please? I'm sorry, I did it with myself. Anyway, so finally, each force, we have two components. For F1, we have the horizontal and vertical component. For F2, we have horizontal and vertical component. For F3, we have horizontal and vertical component. What else? If you are looking for resultant, I'm looking for what is the summation of all of horizontal component. Summation of all horizontal components. What do you have? For F1, we have positive. I believe all of you know this direction of X is positive. This direction of Y is positive. Anything else will be negative. So this component in X direction for F1 will be positive 400. So we have positive 400. What else? For F2, we have this direction, which is negative. How much? 424.2. So we have negative 424.2. What else? For F3, we have this direction is positive. For X, we have this direction is positive. For X, how much? 600. We have positive 600. I think we are done with all forces. So the final answer will be 400 minus 424.2 plus 600. Your final answer will be positive 575.8. Summation forces in Y, which is summation of all vertical components. What do you have? For F1, we have this direction is positive. This direction is positive for F1. How much? 692.8. 692.8 positive. What else? For F2, we have this direction is positive. How much? 424.2. We have positive 424.2. What else? For F3, we have the vertical component in this direction is negative. How much? 250. We have negative 250. Your final answer will be positive 867. What is the unit? It's Newton. So this component is Newton and this one is Newton. So finally, guys, I have horizontal summation of all horizontal component, which is positive. So it will be in this direction. I'm sorry. It will be in this direction. How much? 575.8. And summation of all vertical component is positive. So it will be in this direction. How much? 867 Newton. What is the resultant force for these two current components? This one and this one. I believe your resultant will be like this. In between, your value will be square root of the horizontal one, 575.8 square, plus the vertical one, 867 square. Your resultant force will be square root 1040.8 Newton. And this angle of the resultant force, theta, with the horizontal equal inverse tan, the vertical one, 867, divides the horizontal one, 575.8. I can figure out the angle equal 56.4. So what is the final answer for this problem? Actually, the problem asked for what is the resultant force for F1, F2, and F3. The resultant force for all of these forces, how much? 1040.8 Newton. Where is this force? This force will be with angle theta equal 56.4 with the horizontal. So the resultant force will be here. Here is R equal 1040. And this R with angle theta with the horizontal equal 56. I did all of these calculations because I cannot add F1 plus F2 plus F3 directly, because all of them has different direction. So I need to break each force to two components, each force to two components, each force to two components. Then I can add this horizontal one plus this horizontal one plus this horizontal one. Be careful about the sign. This direction is positive, this direction is negative, this direction is positive. But all of them has the same direction, so I can add them together. Then I will add the vertical component plus the vertical component plus the vertical component. So finally, I have two components only, one horizontal and one vertical. Then I can figure out the resultant value, and I can figure out the direction by getting the value of angle theta. Any question? Any question so far? If you have any question, let me know. One more example. Let me do the last one. We have three forces, F1, F2, F3, but F1 and the angle phi, they are given. F1 equals 600, phi equals 30 degrees. We are looking for what is the magnitude of the resultant force, R, how much? And what is the direction? What is the angle theta for this one? One more time, I cannot add F1 plus F2 plus F3, so I need to break each force to two components. Let's start with F1. For F1, in your exam, please solve like I'm doing. Try to do each step like this. Probably you will get stuck or mistake with a sign or calculation error or something like this. So if you give me the final answer and your final answer is wrong and you didn't do any steps, so you will lose many points. But if you have many steps and I can figure out where is the mistake, so your mistake is only little sign, so you will get -1 only. You know what I mean? So this problem is 20 points or 25 points, you will lose only 1 point or 2 points because you're showing me everything in your calculation. So for F1, here is F1. And the given angle theta or phi equal 30. So I believe we have two components. This component will be F1 cosine phi, and this component will be F1 sine phi. F1 is given, how much? 600. Phi is given 30. So I can figure out the horizontal component. That will be 600 times cosine 30. This value will be 519.6. And this value will be 300, I'm sorry. 600 times sine 30. Yes. What else? For F2, what do you have in F2? Where is F2? Here you go. This one. So we have this direction, F2, and the given angle is 60, theta equal 60 with the horizontal direction. So I believe we have two components, one vertical and one horizontal. The horizontal one adjacent to the given angle, so will be F2 cosine 60. The vertical one will be F2 sine 60. F2 is given how much? 500. So your horizontal component will be 500 times cosine 60. Your value will be 250. The vertical one, 500 times sine 60. Your value will be 433. What else? We have the third one for F3. Actually, we don't have given angle, but F3, we have right angle triangle. This one is 3, 4, and 5. And I'm looking for horizontal component in this direction and vertical component in this direction. We need to pick up an angle, so I will use this one, for example, which equal to this one. So this component will be F3 cosine theta, and this one will be F3 sine theta. So your triangle, which is 3, 4, 5, your selection of angle theta will equal to this one. So sine theta will be 4 divided 5. Cosine theta will be 3 divided 5. So I can figure out the horizontal and the vertical component. If 3 is given, how much? 450. Sine theta, 4/5. Cosine theta, 3/5. So I can figure out the final answer, 450 times cosine theta, which is 3/5. This one will be 270. F3, which is 450 times sine theta, which is 4/5. This one will be 360. Do you have any more forces? No, we have F2, F1, F2, F3. We are done. Then, what is the summation of all horizontal component one by one? Don't forget any. For F1, we have positive 519.6. Next, for F2, we have positive 250. What else? For F3, we have negative 270. Nothing else. Go ahead and find the final answer. It will be positive 499.6. Summation of all vertical component one by one. For F1, we have positive 300. For F2, we have negative, how much? 433. What else? For F3, we have negative, this direction is negative, 360. What is the final answer? 300 minus 433 minus 360. Your final answer will be negative 493 Newton, I think. Is it Newton? Yes, Newton. Be careful. Your final summation of all horizontal component is positive, which means in this direction, 499.6. The summation of all vertical component is negative, which means in this direction. How much? 493. That makes sense for me. The resultant force will be something in between R what is the value of r? Equals square root for the horizontal one square plus vertical one square. I don't care about the sign. The sign is not a big deal for me. The only purpose of this sign to figure out this direction to right or left, and this one to up or down. Your final answer for the resultant force will be square root. Your final answer will be 701.9 Newton. And your angle theta with the horizontal direction equal inverse tan the vertical one, which is, I don't care about any sign, 493 divide 499.6. Your final answer will be 44.6. So can you remember this shape? Your final answer will be the resultant force for all of these forces, F1 and F2 and F3, will be something like this. R, how much? 701.9. What is the angle? Your angle with the horizontal equal 44.6. So this angle 44.6. The resultant force for F1 and F2 and F3 equals 701.9. What is the direction? With the horizontal, we have angle theta equal 44.6. We are looking for what is the magnitude and the direction. Any questions so far? Any question? Okay, so whatever the forces, how many forces do you have? I don't care. Each force must be broken to two components. Then add these components, the horizontal one together, the vertical one together. So finally we have only two summations, one horizontal and one vertical. So I can figure out the resultant force and the direction of this resultant force. We missed something. If you remember, we have three cases of your force. The first one, the force with angle theta is given sometimes, or your force is given with right angle triangle sometimes, or the force is given without right angle triangle or without given angle. But we have a force passing through 2 points. So let me explain the last case. Case number 3. It's not common in 2D, but we need to cover it. It's common in 3D next week. We have a force like F1 or like F. Between this point, which is the first point, I need to go from the first point to the second point in the same direction of the force. So your force is going to this direction. So the first point will be here with x1 and x2. I'm sorry, with x1 and y1 as coordinate, and the second point with x2 and y2. We need to break this force to two components, one horizontal and one vertical. Your force as a vector equal this force time the x component of the second point minus x component of the first point in x direction, I. The y component of the second point minus y component of the first point for j. Divide this difference square plus this difference square. I'm sorry, it's confused to me. No, it's not confused. Let me do it with example. I have a force F equals 600. And this point has coordinate 2 and 4. And this coordinate has this point has coordinate equal 5 and 10. How can I get the components for this force? F as a vector equal this force 600 time. What is the first point? Your force is going to this direction. So the first point will be this one, and the second point will be this one. Okay, go ahead and subtract x coordinate of the second point, 5, minus x coordinate of the first point, 2. So 5 minus 2. This one in x, I. Plus, go ahead and subtract the y coordinate. Y coordinate of the second point is 10 minus y coordinate of the first point 4. So 10 minus 4. J. Divide this subtraction or this difference 5 minus 2 square plus 10 minus 4 square. I can simplify this calculation. 600 time 5 minus 2 is 3i, 10 minus 4 is 6j. Divide this final answer, 5 minus 2 is 3 square plus 6 square under square root. This one will be 6.71. We can simplify this one by multiplying 600 times 3, divide this one. This one will be 268.3i, and this one will be 600 times 6, divide this number, will be 536.51 J. So your force will have horizontal component, how much? 268.3. And vertical component, how much? 536.5. So here is the horizontal component, and here is the vertical component. Actually, it's not common in 2D dimension to find this case. Most of the problem, 100% of the problem in 2D, we have given angle, theta, and or right angle triangle. So most of the time, the first case and the second case are given in 2D. In 3D, we will cover this one in more details in 3D. We have example here. Yeah, this one. Example number 5. If you watch this example, for first force F1, we don't have any issue with F1. F1 is given with angle theta equal 35. Normal. F2 is given with right angle triangle 3, 4, and 5. Normal. So we can break these forces to 2 components. But for F3, we don't have angle. We don't have right angle triangle. But we have 2 points. point A and point B. Here is the x-axis and here is the y-axis. So I believe your origin will be here. So can you tell me what is the coordinate of point A? What are the x and y coordinate of point A? So from the origin, 0 and 0. If you would like to go to point A, I need to move in x direction how much? 0.2. I need to go up in y direction how much? 0.1. For point B, so I need to reach from the origin to point B. So I need to move in x direction how much? 0.4. I need to go down in y direction how much? Negative 0.3. So finally, we have a force F3, how much? 800. The first point, point A, with coordinate 0.2 and 0.1. The second point, which is B, with coordinate 0.4 and minus 0.3. I think I can figure out the component of this force. Like this. So F3 as a vector equal F3 800. Then, what is the first point? I believe this one is the first point because your force is going to this direction. So the first point will be here, the second point will be here. So the x coordinate of the second point minus x coordinate of the first point will be 0.2i. Y coordinate of the second point minus y coordinate of the first point will be minus 0.4. Divide this one square plus this one square. So finally I can get a number I plus another number j, which is the horizontal component and the vertical component. Any question? It's very important in this part of the course to figure out how can I get the x component and y component for a given force with angle theta given or right angle triangle given, or sometimes the coordinate of 2 points are given. Very important. Next week, I will do the same. I will repeat all of this stuff, but not in 2 dimensions, not in x and y only. No, we will have x and y and z direction, or whatever. This one is x, this one is y, and this one is z. So we have 3 dimensions, force in 3D. I will repeat all of these cases. What will happen for 3D, we don't know. Let's do it next week. But for now, do you have any question? Could you go over number 4 on the homework? Yeah. Okay, go ahead and think about number 4. Alex, number 4 is very easy, but I will go through it quickly. Just a second. Engineering mechanics homework number 1. Where is number 4? Here is number 4. That's right. Determine the magnitude and the direction theta of F1. So F1 and the theta are unknown. That's right. I don't care. I don't care about anything. I don't care. F1 with horizontal and vertical component, this angle equal theta plus 30. I believe you agree with me. So I will have F1, I don't know, cosine theta plus 30, I don't know. I cannot figure out the final value here. F1 sine theta plus 30. You agree with me? For F2, we don't know, we don't need to break this force because this force has only one component in X. We don't have anything in Y. 0, just F3 in X, 200. What about F2? For F2, equal 450 with angle 45 degree, so I can figure out the horizontal component and vertical component. Do you agree? Okay, I know theta and the F1 are not given. I don't care. Go ahead and get the summation F of X for all of these components. So add this one plus this one plus this one and put it here. We still have F1 and the theta unknown. Summation F of Y, but this one, which is negative, we don't have anything here, plus this one, so you will get the value here. Your value also will be a function of F1 and theta. Do you agree with me, Alex? Until this moment, nothing new. Nothing new. Everything is the same. Please go ahead and read this sentence. The resultant force directed along the positive x-axis and has a magnitude of 1000 Newton. The resultant force R equal 1000. And what is the direction? It's in the direction directed along the positive x-axis. So I am good. Here is the resultant force. We don't have anything in y direction. What you got here? We got two components, summation f of x plus summation f of y. So I can say your resultant force equal square root of summation f of x square plus summation f of y square. So I know this one. I know these values, which is function of theta and f1. Or the best answer, your R, which is the resultant force, break it to horizontal component and vertical component. Actually, we don't have vertical component, it's 0. We have horizontal component 1000. So I can say summation f of x equal 1000 and summation f of y equal 0. This is the best solution. So this kind of problem, please go ahead and pick each force, whatever. Do you have the force or not? Then go ahead and get the summation of all horizontal component and vertical component. Then go ahead and read what's going on with the resultant force. If the resultant force is given with angle theta, go ahead and get the horizontal component of the resultant force, the vertical component of the resultant force. This horizontal component equal to summation of x. This vertical component equal this one. So we have two equations and we have two unknowns, theta and f1, so we can figure both of them. It's a good problem. Please try to do your best. I will not deduct any point for this problem. Don't worry. But try to think.